Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about this problem. So let's get started. So the problem is given as you are given two numbers n and k, and you have to find that if the kth bit of number n is set or not. So let's understand this with examples. So let's say n is equal to 2 and k is equal to 2. Then you need to find that if kth bit of number n is set or not. So the binary representation of number 2 is 0010, and here the second bit is set and k is equal to 2. It means second bit is set, so the output of this input is true. Next example is if n equal to 3 and k equal to 1. Here our task is to find if first bit is set or not. So the binary representation of number 3 is 0011 and first bit is set, so the output is true. In next example, the number is 6 and k is equal to 1. Here the first bit is not set, so the output is false. So let's pause this video and think about a solution to solve this problem. So let's first see that how we check if a bit is set or not. So now let's consider only one bit. Let's say we have only one bit 0. So if we multiply 0 by 0, means binary multiplication, we get 0. And let's say if bit is 1 and if we multiply 1 with 0, we get 0. So in both the cases we are getting 0. But what if we multiply 1 with 1? We get 1, because 1 into 1 is 1. So after looking at all the three examples, we come to the conclusion that if we multiply 1 with 1, we get 1. It means we can figure out that if the bit is set or not. How? If the bit is set, it means the value of bit is 1, and if we multiply 1 with 1, we get 1. It means the bit is set, right? Moving on. So let's say, what if I prepend 3 zeros before this bit, because this binary representation is equivalent to 1 in decimal, right? And what if I prepend 3 zeros to this bit? This also becomes 1. And if I bitwise AND both the numbers, we get 1. Right? And that is not equal to 0. So what we can learn from this experiment, that if we want to check that if the first bit is set or not, then we have to simply bitwise AND with 1, and we get a number that is not equal to 0. It means the first bit is set. Clear? So remember this fact. We are going to use this fact later to solve this problem. Okay? So moving on. Let's say now the number is 3. So the binary representation of number 3 is 0011. And I want to check if second bit is set or not. So to check if second bit is set or not, we need a number whose second bit is set, and that number is equal to 2, because in 2 only the second bit is going to set, and if we bitwise AND both the numbers, we get a number that is also not equal to 0, right? So it means we can learn from this experiment that if we want to check if kth bit is set or not, then we need a number whose kth bit is set, and else other bits are 0, and then we bitwise AND both the numbers, we get a number that is not equal to 0. It means the kth bit is set. Okay, so remember these two facts. Now let's moving on. So let's discuss about the first idea to solve this problem. The first idea is find a number whose kth bit is set and perform bitwise AND with that number. Right? If we get a number that is not equal to 0, it means that bit is set. Now the question is how to find number whose kth bit is set. So let's see it. So as we know that the binary of number 1 is 0001, right? So can we shift this bit to other position? Correct? Right now the first bit is set, right? So can we shift this bit to other position? Obviously, we have learned in previous videos that we can use left shift or right shift operator to shift the bits. So here also we can use left shift operator to shift the bits. So let's say k equal to 2. It means I want to check if second position of bit is set or not, right? So currently the bit is at the first position and I want to move this bit to second position. So how many position we need to shift? Obviously 1. So if we do 1 left shift 2 minus 1, that is equal to 1 left shift 1, we get 0010, right? So now our 1 is at the second position, correct? So we got our number whose kth bit is set. So now we can simply do bitwise AND with the number and we get the output. Okay, this is the first way. Now there is also a second way to get a number whose kth bit is set. Now let's see the binary representation of any number. Let's say this is the binary representation of any number xxxx, right? So here each bit is representing the power of 2, right? So let's say if I set only one bit and left all the remaining bits as 0, so I get 1, okay? Second, if I set second bit, I get 2. If I set third bit, I get 4, and if I get fourth bit, I get 8. So it means when I am setting any bit at 0th position or 1st position or 2 or 3rd position, we are getting a number, and that number is a power of 2. So let's say if I want to get a number whose kth bit is set, it means second position, right? So in second position, what is the power of 2? That power is 1. So we can simply find that number by doing 2 to the power k minus 1, right? Because if the position is 2, then the power of 2 is 1. If position is 3, then the power of 2 is 2. If position is 4, then the power of 2 is 3. So we simply get our number by doing power of 2. So if 2 to the power 1 is equal to 2, it means we get a number whose second position bit is set. And now what we can do, we can simply bitwise AND with the number and we get our output that the bit is set or not. So this is one way. So we have total two ways to find a number whose kth bit is set. One is we can use the left shift operator and shift bit by k minus 1, or we have another option to raise the 2 by power k minus 1. And which is the best approach? Obviously left shift operator is the best approach because left shift operator, it means bitwise operators are much faster than other operations. Okay, so here you see the implementation of this solution. So what we are doing basically, we are simply finding x, and x is what? We are shifting 1 by k minus 1 bit, right? Because as we saw that in 1 the first bit is set, so we are simply shifting this bit to x position or k position. So we get our x, and we simply have to do bitwise AND with the n. If we get not equal to 0, it means the bit is set. If we do not get not equal to 0, it means bit is not set. So let's say in case of 5, if n equal to 5 and k equal to 3, the binary representation of 5 is 0 1 0 1, okay, and the binary representation of 1 is 0 0 1. So after shifting by k minus 1, our 1 gets shifted to this position because k minus 1 means 3 minus 1 is equal to 2. So we are shifting by 2 places. So first 1 gets come here, then 1 gets come here. So our 1 finally comes at this position. Now what is our n? N is 5. Then binary representation of n is 0 1 0 1. And if we do bitwise AND of both the number, we get 0 1 0 0. And this is not equal to 0. It means the third bit of 5 is set, and we can see clearly that third bit is set. Okay, so this is the first approach to solve this problem. Now let's move on to see the second approach to solve this problem. We begin the second idea by knowing the fact that if we want to check if first bit of a number is set or not, what we do, we simply bitwise AND that number with 1, and if we get not equal to 0, it means the bit is set, right? So let's say the number is this 0 0 1 0. So can we shift this bit to right side? Means can we do like this 0 0 0 1 means we are shift. So it means can we shift this bit to first position? Obviously we have learned about the right shift operator. We can shift bits towards right by using right shift operator, right? So let's see first way to do this. So the first way to do this is simply using the right shift operator. So in case of n equal to 12 and k equal to 3, I want to check if third bit of 12 is set or not. So the binary representation of 12 is 1 1 0 0. Okay. Now if I want to check third bit is set or not, and if you want to use the previous fact, then I have to move this bit to this position. Correct? So how many positions we have to shift? 1 and 2. But k is equal to 3. So how many shift we need? K minus 1 shift. So after shift, our value of n becomes 0 0 1 0. See, this bit comes here and this bit comes here. So it becomes 0 0 1 1. Now our task is simple. Now we just have to bitwise AND with the 1 and we get 1. And that is not equal to 2. It means third bit of 12 is set. So this is one way to solve this problem. Now let's move on to second way. And what is the second way? We know that right shift means dividing number by 2. And we have learned this in previous video that whenever we do right shift, we are reducing the power of 2. It means we are reducing power of 2. It also means when we divide number by 2, the power gets reduces, right? So let's say if n equal to 12 and k equal to 3, the value of n is 1100, and this is the binary representation of 12. So when we divide 12 by 2, we get 6, and the binary representation of 6 is 0111. So you can see that this bit is now shifted here, right? And we again divide 6 by 2, we get 3. So as you can see that all the bits are shifted to right side. Okay. Now this bit comes over here and this bit comes over here. So we get 0011. So how many times we are dividing number? If k is 3, we are dividing number by 2 times. So if k is 3, we are dividing number by 2 times. So it means we have to divide number k minus 1 times to get our bit shifted to first position. Okay. Now our task is simple. The bit is at the first position, right? The third bit, the third bit is at the first position. Now we have to simply bitwise end with 1, and we get 0001, and that is not equal to 0. It means that the third bit of 12 is set. Again, we have two options to do this. First, use the right shift operator or divide number by 2. Obviously, we are going to use right shift operator because it is much efficient and much faster. So let's see the simple implementation to solve this problem. So what we are doing, we are simply shifting the bits of n by k minus 1 position, right? So if n equal to 12, k equal to 3, binary representation of 12 is 1100. If we shift the bits by 2 position, both the 2's moves here at this position, and we simply doing AND with 1, bitwise AND. Okay, so we get a value that is not equal to 0. And the output of this is true. Clear? So we have discussed two approaches to solve this problem. Approach 1 is find a number whose kth bit is set. And how to find that? Simply doing left shift operator with 1, and we shift and we left shift bit by k minus 1 position. Okay. And the second approach is simple. Shift bits of a number n towards right side by 2 minus 1 position. It means k minus 1 position in case of k equal to 2, 2 minus 1. And then simply bitwise AND with the 1, and you get a number that is not equal to 0. If number is not equal to 0, it means kth bit is set. Okay, clear. Now if we talk about the time complexity of this function, then we are simply doing some bitwise operation, and that is as same as any operation, arithmetic operation or like this. And even the bitwise operators are much faster than arithmetic operation. So as we are doing only constant operation, it means the time complexity of this solution comes out to be theta of 1, and that is a constant time. So now I hope you have a clear understanding about how to find in any number that if kth bit is set or not. And I have shown you two approaches to solve this problem. Either you find a number whose kth bit is set, or you just shift number by kth bit and do bitwise AND with the 1, and you get your answer. Okay, so this is it for this video. Thanks for watching. See you in the next video.